Good morning, everyone. I'm just going to jump straight into it so we can try to get you done and on with your business early today. As Mary Beth said, we're going to do a little bit of 101 on Amazon Web Services. I'm going to try to give you a pretty good overview of what everything is so that you have a little bit better of an understanding of how it works, how people are using it, and how you can actually start using it. First few slides are going to be just an overview / introduction to AWS. Excuse me. So AWS provides quite a service offering to support pretty much any workload that you could have. On this particular slide, I'm going to start from the bottom and work my way up because everything is kind of a layered stack here, and you can't have one without the other. So starting with the AWS Global Infrastructure, we're going to cover this a little bit more in detail in the next few slides, but AWS provides resources in various regions and availability zones around the world. This will help you keep your content or your servers close to where you need them, and also provides you with a mechanism for high availability and failover. Next, on the networking layer, this is how you both connect to your resources in AWS and how your resources that are in AWS communicate with each other and with the internet or your on-premise resources. With this layer, we're going to cover this a little bit more in detail later in the presentation as well, but just know that there's a few things here. You can connect to AWS resources through a typical VPN over the internet. You can connect to them directly over the internet, or they offer a service called Direct Connect, where you can actually have a direct network connection straight into an AWS data center for really fast, low latency connections. The next step is kind of all at the same layer. So compute, storage, and database, these all work together. On the compute level, these are our EC2 instances. This is probably the most familiar aspect of AWS to most people. These instances are akin to your virtual machines or your physical servers that you're used to working with. AWS provides many options on the configurations of your resources, from really basic cookie cutter, this is how much memory you get, this is how much CPU you get, to pretty customizable things with memory or CPU optimized instances. On the storage side, again, there's lots of options here. Probably most familiar to people is S3 storage, which is basic object storage. This would be things like storing images, small files, documents, and as I'll cover a little bit more in detail later, provides a really good backup solution. If you're a Dropbox user or are familiar with Dropbox, all of your files for Dropbox are actually in S3. Another type of storage is the elastic block store. These are typically what you would connect to your EC2 instances, and they would serve as basically the hard drive. This is where you install your operating system and save any static files that are necessary to run a server. Whatever's on an elastic block storage volume stays there until you tell it to go away. And then the final storage type is an instance store. It's similar to the elastic block store, but it's temporary. So if you're in a use case where maybe you have a whole bunch of front-end web servers or a server that you might consider dynamic or throwaway, instance store is really cool because they give it to you for free. The current generation is all flash storage, so it's really fast. The only caveat to it is if you turn the instance off, whatever's stored there goes away. So you have to you have to kind of make sure that you're running the right things on the right storage. Next at this layer are the databases, and this can get a little bit confusing to some people, but you basically have two options with the way you run your databases in AWS. One of the ways is you just install your database server in an EC2 instance and you manage it yourself, the way that you're really used to doing. Alternately, AWS provides a service called RDS, which stands for Relational Database Services. You can select from quite a list of database servers, Microsoft SQL Server, MySQL, Oracle. There's quite a list, and I can provide a link at the end of the webinar for that. But if you run these on RDS, Amazon does a lot of the back-end management, keeping your server updated. If there's a patch for the database server, they actually manage patching that at maintenance intervals that you tell them. And they also make it really easy with just a few mouse clicks in a replica database up, or upgrade the size of your database. It's pretty cool and really alleviates some of the administrative burden on the databases. Next is the application services. So if you're running a web application or a custom application, AWS provides things like queuing services, email services, notification services that are all exposed through their API that are really simple for you to customize your code to integrate with, so that you can take advantage of those instead of having to manage an application as part of your infrastructure. And then on top of that, the deployment and administration layer. There's a lot of stuff that you can do here. I think probably the most common things that people are interested in are the way that you deploy your instances and the way that you scale them. For example, they offer a solution called autoscale, where based on any number of metrics that you decide, you can have Amazon automatically create a clone of an instance that's running to handle a higher demand than you're used to, and then shut it down when your demand decreases. Talk a little bit more about the global infrastructure with the regions and availability zones. This is a current map of where Amazon currently has regions. Within each of these regions are at least 2 availability zones. I know for a fact that the US East region has A through E, so there's quite a bit of options there. But the basic premise behind availability zones is that they are separate data centers within the same region. So to talk a little bit more about the US East region again, those data centers, they're all in the DC area, but an availability zone might, one availability zone might be, say, in Baltimore, another one might be in Arlington. So these data centers are on separate power grids, they have separate internet connections, and that's just there to basically prevent complete loss in the event of a disaster. So if something happens and one of those data centers is taken out, if your infrastructure is out there in a manner that it's balanced across these availability zones, you should, in theory, see no loss to your service. And also on this map where it says edge locations, AWS has what they call CloudFront, which is a delivery network. This would be used by probably your websites. It caches your images, your videos, your documents, any type of static content to help keep things quick. When you use CloudFront, it replicates all of this content to the 51 locations around the world, so that regardless of where the customer that's hitting your site comes from, they're getting the closest, which means the quickest, well, likely means the quickest transfer of the content. And it also helps alleviate some stress from your servers because their traffic is going against the edge locations provided by Amazon instead of your own instances. This slide just shows some of the well-known Amazon customers. I think it's a really good demonstration to show, that there's a lot of well-known people that trust Amazon with their infrastructure, with their data, with their traffic. Likewise, there's a lot of government agencies, schools, people like NASA. Again, they all trust Amazon with their data. There's, if you're interested in the Gartner quadrants, Amazon is basically an overwhelming leader on that quadrant. There's only like one other dot in the same box as them at this point. They've been around the longest in this market, and they have the largest infrastructure, and seem to put out features before other people. So why are businesses choosing AWS? First, we should probably touch on security. It seems like there's a fairly common misconception that AWS isn't secure. In reality, Amazon has put a ton of time and effort into meeting and really even exceeding some of the most demanding security accreditations. According to some of the white papers that Amazon has published on this topic, some of their biggest, most conservative customers from industries like healthcare, pharmaceuticals, finance, even the government, they found that Amazon is able to meet their security requirements and oftentimes even provide a better security profile than what they could have delivered on their own. The security controls that they've implemented to meet all of these requirements, they kind of flow down. It's a pretty big win for smaller customers because we get to take advantage of all of this without all of the extra overhead. It's just built in. Something that I always like to keep in mind with security when I'm thinking about AWS and the cloud is this is the same exact platform that Amazon uses themselves. So every time you buy something on Amazon, you're using this platform. Myself, as someone who spends quite a bit of my paycheck on gadgets from Amazon, I'd really kind of like to believe that they're doing this part right. If you want to learn a little bit more about the various security certifications, accreditations, controls, etc. that Amazon has, they've published a pretty good white paper and have an entire security section available on their website. We just pasted that into the chat, so feel free to take a look and let us know if you have any questions on any of the stuff that you find there. Another reason is you can lower your costs up front and kind of increase the way you save as you grow in Amazon. So to cover on each of these points that we see on the slide here, with number one, take the example that you don't really know exactly how many resources you need to start a project or to move forward with running your applications. Instead of buying a whole bunch of hardware up front, possibly risking totally over-provisioning and wasting a whole bunch of money or not purchasing enough resources, in Amazon you can do exactly what you need to run your load and scale up from there, or scale down as well. For number two, economies of scale. This is really just kind of like economics 101 type stuff, supply and demand. AWS, the infrastructure keeps growing, more and more companies keep using this, So the price has really kind of gone down. Over the course of the last few years, Amazon has actually had 38 price reductions on their service. I don't have the exact percentages on these. If anybody's interested in that, I can certainly help find it. Number 3, pricing model with variable and stable workloads. Basically, you have a few different ways that you can pay for your service in Amazon. The most basic way is on demand. So if you have something that you just need to run really quick, maybe it's not going to be out there for long term, you're just testing things out, you use the on-demand option, you just pay as you go per hour that that server is running. This is the most expensive option that they have. Next, Amazon has reserved instances where, similar to a contract, you tell Amazon that you're going to have a machine running in their infrastructure for a certain amount of time. Currently, this is at 1 or 3 year intervals. And the way these work is you pay them an upfront fee, which lowers your hourly rate. We help customers plan for this, for purchasing reserved instances quite often. In a few cases where they have servers that are running 100% of the time, 365 days a year, we've actually seen the price over the course of a year drop by about 50% compared to on-demand pricing with this model. And the next pricing model is spot instances, which is a really neat concept. I'm yet to really have to play with the spot market, but essentially there is a marketplace where there are resources available for partial use that you can just bid whatever you want. Say you're willing to pay 5 cents an hour, you bid 5 cents an hour, and hopefully you get it. This is really good for short-term workloads, maybe processing data, just putting some extra power towards your workload. A really good use case for this that's pretty well known is Netflix. They purchase a whole bunch of spot instances overnight to help transcode their videos that we all like to watch. And it saves them a whole bunch of money. And on number 4, save more money as you grow bigger. AWS offers tiered pricing, volume discounts, and even some custom pricing for larger implementations. If you think you're big enough for this, let our sales folks know. They can work with you, work with Amazon to try to figure out what they can do there. Another reason that people are going to Amazon is innovation. Like the slide says, businesses can't afford to be slow. I read an article recently that it talked about how much AWS has positively impacted the number of successful startup businesses because of how easily and accessible its resources are for people to use. In this particular case, you may only need a handful of instances to get started, but maybe your startup has this great idea and you're going to be the next big thing and you're just going to take off. So if you've provisioned in Amazon, you can scale up to meet these huge demands in like minutes with very little effort. Instead of having an idea and just kind of passing on it, you can add your resources to Amazon and test your idea, see if it's worthwhile to move forward on, and who knows, maybe you'll have that next big thing, and you could have missed out had you not provisioned these servers. A common myth about getting to the cloud and Amazon is that it's basically all or nothing. You have to keep all of your resources on premise, or you have to move everything in one fell swoop up to the cloud. This is not true. There's a lot of different integration points where you can take a slow approach, or you can keep some things running on-premise, have some things running in the cloud. Some examples of this, of how some of these integrations work. On the right-hand side of the slide are some of the Amazon features. On the left-hand side are things that you're used to in your own network, and kind of how some of these map. So IAM, which is the way you control your users and permissions inside of an AWS account. This is pretty cool because it can actually be integrated with your Active Directory or various single sign-on providers, so that you can log in to your Amazon account using credentials that you already have and control access to the resources based on those credentials. At the network layer, VPC, we touched on this a little bit earlier, but it's basically it's a private network segment that you set up in AWS. It segregates you from everybody else that's running in AWS, and it makes just a nice logical separation of your networks, just like it would in an on-premise network. If encryption is something that's a big deal for you, there's plenty of encryption providers in AWS. If you're using S3, you can just turn encryption on for the bucket for where your files are. Everything that's in there is encrypted. You can encrypt the elastic block store volumes. If you wanted to, you could also use traditional methods of encryption, encrypt your files before you put them out there, or in your EC2 instances, just use the operating system level encryption. For backups, there's a lot of ways, again, that you can use AWS for backup. I think one of the most common is, and we'll touch on this a little bit more in detail, but you can back up any data that you want to S3, and then using policies within S3, you can migrate that data into a product called Glacier, which is extremely inexpensive storage, so that you can store things long term, maybe to meet your requirements for archival or something like that. And as I touched on, there's also Direct Connect, which connects your network directly into an AWS data center, so that you have fast, low latency, and secure transfer of your data to your resources in Amazon. So what are businesses using AWS for? Basically everything. Applications, their development and test environments, big data and high performance computing, disaster recovery, maybe they move their mobile applications out there, maybe they host only their websites out there. The options are, in all honesty, limitless. You can even host VDI out there. I'm going to go through these next few slides kind of quick. I'll stop a little bit longer to iterate some important points, though. So these are some of the more well-known clients of Amazon. And basically, these are people that are known to either have entirely replaced data centers, or who are just running everything in Amazon. Again, I'm going to focus on Netflix. I like to watch a lot of movies. I think they're pretty familiar to a lot of people. So Netflix runs, as you can see here, almost entirely out of AWS. They've done that from day one. 98% of their resources run on AWS. And another cool statistic I've recently read is that at certain points of the day, like 1/3 of all internet bandwidth actually comes from Netflix, and that's all run out of AWS. So that's pretty cool. They have tens of thousands of servers out there. It's just such a great use case. Business applications. So there's a lot of people who have certified their applications to run in AWS. Here we have Oracle, SAP, Microsoft, just to name a few. One of the neat things, especially with Microsoft, is that if you launch a Windows instance, you can bring your own licensing if you want, or if you don't want to deal with the licensing, you can actually choose a cost model where the price you pay for your instance includes the Windows licensing. So it relieves another administration point there of trying to figure out how many licenses you have, how many you need if you're in compliance. There's some pretty cool things on the Microsoft side that you can do. I mean, you could run your SharePoint, you could run your SQL servers, you can do your Exchange. For a little shameless plug, we worked on an Exchange test drive through the test drive program at Amazon, and I can give you a link to that, where you can actually fill out your details, click a button, and launch a fully functional multiple availability zone Exchange environment in AWS. You can use it, you can send emails, and after 4 hours it'll kind of self-destruct. But it's a really good example of how a lot of the things that we've already talked about work, and I think it's a really great example of how you can automate an environment in AWS. Another thing people are using AWS for is their development and testing environments. I've found in my experience a lot of times your dev and test environments end up being on old hardware that you just kind of had laying around. It's prone to errors. You don't have enough of it to do what you need. So AWS is great for that because you can put whatever you need out there and get rid of it when you're done. Big data. Amazon has Elastic MapReduce and Kinesis products, which are out there for you to handle massive amounts of data, process your analytics, get reports, find out what's going on in your data. You get to use the power of their resources instead of trying to build your own clusters to do all of this work. And similarly with high-performance computing using, again, Elastic MapReduce or Redshift. We talked a little bit about this a little bit earlier, but here's a really simple use case for backing up. AWS has a product called the AWS Storage Gateway, and this is an appliance that you actually put on-premise that links your storage system into S3. So you set policies, what do you want to replicate up to S3, store all of that data there, and then on the S3 side you create policies to move that, either delete that data when you're done with it and don't need it anymore, or archive that out to Glacier so that you can meet your retention policies and things like that. Typically, if you're using something like this, Direct Connect would probably be in the picture as well, so that you have really high-speed transfer rate to get that data into the cloud. Disaster recovery. This one to me is very similar to the dev and test environments that you might do in AWS. Again, I've found in my experience, you've either got a disaster recovery budget or you don't. So a lot of times your DR ends up on really old servers that are going to break or might not be able to handle all of your load in the event of a disaster. You can spin up the environments that you need in AWS, get your data out there, and recover from a disaster very quickly. Or you could take a hybrid approach and run your services either on-premise and in AWS at the same time, so that if something fails, it's already up and running. So how are businesses getting started with AWS? We've covered most of this stuff already, but to just kind of reiterate, one of the first strategy is use AWS for development and test environments. It's out there, you can use it, it's easy to automate, and quick to create a test or a development environment to get you going. Strategy number 2, just start building your new application or applications in the cloud. You've already spent the time, you have all the infrastructure running your current stuff where it is. Leave it there for now, but as you move forward, start bringing things into AWS. Number 3, backup, like we keep talking about, data analytics, data warehousing, disaster recovery. Start using AWS as a solution to accomplish those tasks. Number 4, integrate your applications between AWS and on-premise. The example I can think of for this, maybe you have a web application where you sell things, and it might be really simple for you to move your web servers out to the cloud, take advantage of the CloudFront content delivery, but you're not quite ready to move your purchasing application out there. So go ahead and move the web servers, leave your purchasing application on-premise until you're ready to move it, and then operate in a hybrid mode like that. Next, you could just start migrating any existing applications you have to AWS. Similar to when we started migrating from physical servers to virtual servers, pick the best workloads that you see fit to begin migrating and take the slow approach. Or strategy 6, just go all in. Especially if you're small and starting out, this might be a good approach. Follow Netflix's lead or other companies who have already done this, and just put everything out there. And finally, a few Apparatus client use cases and how we're using AWS. Entire infrastructures. We have a client. They're an East Coast newspaper provider, and everything they do is in AWS. This includes auto-scaling, so the news is has pretty predictable patterns in usage, so we know when their website's going to have high amounts of traffic, typically at like 8 a.m. when everybody's drinking their coffee and trying to get in the right mood to start working. We can automatically put a server out there to handle the extra load, and then bring that server back down when the load spike kind of dies down. And it keeps everybody happy because the news that they want to see loads quickly, and it really kind of helps prevent problems on the back end by not putting too much stress on the servers that are out there. Extreme utilization peaks. Another client of ours, we helped them migrate one of their applications to AWS. Most of the year they don't have very much traffic to this application at all, but during basically 1 month of the year they're very busy, and on one weekend of that month they are extremely busy. This year, with this application running in AWS, they were able to, with about 5 mouse clicks, go from 1 running server to about 20 running servers, and they were able to handle in the neighborhood of about 800,000 unique requests per minute on this web application for the period of about 5 hours. The website was quick, responsive, it did exactly what it needed to do. Another use case that's pretty common, processing additional workloads. In this particular use case, when new code deployments happen, it has a tendency to, it's just the way the application is designed, but it knocks devices off of the servers that they're on. So we need to process all of the connections in a certain manner. So, well, while this client does their deployments to their on-premise servers, we can spin up a whole bunch of extra worker servers, direct the traffic to those, and the devices on the end don't even know that anything has happened. When the deployment's done, we turn those servers off in AWS. They go back to the servers that they were running on previously, and everybody's happy. And finally, another use case that we use is just helping people migrate to the cloud. One particular use case that we see, you have an application hosted on-premise, and the usage of the application is beginning to grow pretty drastically, and you just don't have the resources to handle that growth. So we can help move that application into AWS so that we can help you scale as quickly as you need to, including helping automate that scaling so that we kind of keep the administration down to a minimum, so that even though the application is getting more usage, we don't need to spend equally as much time on the application. Does anybody have any questions for us?
All right, if there's no questions, then we'll go ahead and wrap things up. Brian, thank you very much for presenting AWS 101 Journey to the Cloud, and thank you all for attending.